Okay, let's review for our Unit 2 test, which is coming up. And we're going to do it the way we did before. We're going to go over the main points that you need to know out of each of the sections: 3A, 3D, 3E, and I think that's about it. And then we're going to do some practice problems in each. Okay, so the first thing we talked about was some basic rules on going between percents, decimals, and fractions. Okay, so let's talk about a fraction to a decimal. Actually, let me turn that light on. There, now you can see a little bit better. Okay, so if I have a fraction to a decimal, all you do is divide, because that's what a fraction is. Okay, if I want to go from a percent to a decimal, let's say I start with 23.5%. Then to get to a decimal, I'm going to move this 2 places to the left, and that becomes 0.235. If I want to go from a decimal to a percent, let's say I have 1.37 and I want to turn that into a percent, I go 2 places to the right and that becomes 137%. Okay, so we know how to do this. Okay. All right. Well, now the next thing we talked about is the percent equation. This is so important. You need to know this. Any of you who are taking shortcuts, and you'll see in some of the examples that we do, that is, you really, really need to learn this equation. We're going to do percent times the reference value is equal to the compared value. Okay. And of course, the percent, what you're going to see is probably a percent symbol. The word of equates to multiply. The word is or was is the equal sign. And the thing you want to remember as you're setting this up, and what you may not remember, is that these two items are the same thing. As a number and as a percent. And again, you'll see when we do some practice on that. Okay. Okay, so that was the basic equation that we did in 3A. And then everything else kind of fell along with that. So let's talk first about percent increase and percent increase. Okay. If we have a percent increase or a percent more than, you're going to start out with 100%, and then you are going to be adding to that some portion here, P. This is your reference value plus your percent increase. So another way of saying this is 100% plus P is equal to your percent of. and we'll talk about of and times. Okay. If I have a percent decrease or a percent less than, I am going to have my reference value, I'm going to start abbreviating, which is 100%, and I am going to remove some portion. So all I have left is this. So it's going to be the reference value minus the percent decrease. So equating it here, if I have 100% minus the percent decrease, that is my percent of. Now, an example of this would be if you were talking about a discount. The percent decrease would be your the amount of the discount. 100% minus that percent is going to be your percent of. Okay. Okay. Now, talking about percent of versus times. What I want to emphasize here is times is percent of as a decimal. And we just talked about how to convert a percent to a decimal. Okay, so let's talk about absolute and relative change. They are related. Absolute change is a number. An absolute change is how much something has changed. If it's a price, if it is a, I don't know, whatever it is. And it is the compared value minus the reference value. Okay. If it's positive, that's an increase. The value went up. If it's negative, that is a decrease. Okay. If you buy a house, chances are the value is going to go up. If you buy a new car, chances are the value is going to go down. Now your relative change or difference, this is not a number. This is a percent change. Okay. And there's a formula for it which you're going to use for more than just this section. It is the compared value minus the reference value divided by the reference value, which is the same thing as saying absolute change divided by reference value. Okay. But the note here is you have to change to a percent. Okay, so I think that's all for 3A. Okay, then we go to 3B. I forgot about 3B. 3B was all about scientific notation and using that for energy comparisons. Okay. Now, the thing I want to impress upon you here is for scientific notation is you want to know how to use your calculator. That's going to be key. Scientific notation is A times 10 to the n, where this is between 1 and 10. This is an integer, which means it can't be a fraction or a decimal. Okay. And there are a couple of things here. If n is negative, it's a number smaller than 1. If n is positive, it is a number larger than 1. And the other thing that you may want to make note of in here, things that you might want to be aware of are you may want to know million, billion, trillion as powers of 10. Okay, then energy comparisons. We had a table here, and you have that you will have a table available to you on the test. And knowing exactly what these means. The energy released by metabolism of one average candy bar means one average candy bar is 1 times 10 to the 6 joules. So making sure you are understanding, if you need to take the time to do that or whatever, but make sure you understand how to read this table is key. Once you understand how to read the table, then the easy part of this is you're just doing unit conversions. And your unit conversions is from unit 1, where you know you have equivalent fractions. Okay. So you are going to start with the given information over 1. Then you are going to go in here, and however many times you are going to cancel units until you get to the units you want over 1. Or it may not be over 1. It may have a denominator. And then that will equal the units you want. So we talked about liters of coal. If you start about with how many liters does it take to heat a house for a year? You would maybe start with a year, end up with liters, or however. Each problem is going to be different, but all you're doing is unit conversions. Okay. All right, then 3D was about the consumer price index. Now the good news is we are going to give you these formulas. Let me grab something real quick here. There are only 3 that you need. Okay. So if you are comparing quantities or comparing CPIs, you are just going to take the larger divided by the smaller. And make note, if you're given stuff in scientific notation, at scientific notation, the larger exponent is the larger number. And again, these could be CPIs. Okay, finding something's cost due to inflation. If you know what the cost of something was in 1980 and you want to find out what it should cost today, you can do that, and there's a formula for it. Okay, and the formula is the price in year Y is equal to the price in year X over 1 times the CPI in year Y divided by the CPI in year X. Now, you can think about this kind of like you can units. You want to end up with year Y. If you can cross out year X with the price and the CPI, those are the equivalent. Okay. Okay. Now, the rate of inflation, once again, this is something we've done before. All it is the relative change formula with CPI, your consumer price index. So it is the compared CPI minus the reference CPI divided by the referenced, or the reference CPI. Now here's the deal. You're going to be given these formulas, but you have to know how to use them. We're not going to title them for you. So you will be given the formulas. But you certainly need to know how to use them. We're not going to tell you that part of it. Okay, then the last topic we covered was the false positives and false negatives. Okay. And the thing that I wanted to impress upon you here is we've looked at two-way tables before, but I would take the table and I would, all of these you're going to know by tested positive and positive. So that is true. Tested negative and negative is true. These two are false. But label these totals what they actually mean. This is the total tested positive, the total tested negative, the total that are positive, the total that are negative. And we're going to see how this goes in a little bit. These are the results that are accurate. And these are the results that are not accurate. Okay. And I also forgot to say, you will also be given a CPI chart, so you won't have to know those by any stretch of the imagination. Okay, so that's that. Let's go ahead now and start doing some practice problems. Okay, since the week of Snowvid, the price of gasoline at a local station is $2.39 a gallon. Prior to Snowvid, the cost of gasoline at the same station was $2.03. What is the percent increase? Okay, well, this we're going to use our percent equation. Okay, so we're going to find some percent of a reference value is equal to the compared value. Okay, now I'm going to show you two ways of doing this. Okay, so the percent increase is what we want to know. That's going to be, what is the percent increase? The reference value is where we started. So our reference value is going to be 203. And that is equal to our compared value, which is 239. Okay. So this gives us the equation x times 2.03 is equal to 239. Of course, I know I have to divide by 203. And I get that x is 1.177, or 117.7%. But we want to know the percent increase. So if I look at this 117% is my reference value plus the percent increase, which is 100%. So this is going to be 17.7%. So to answer, the amount of the increase is 17.7%. Okay. All right. Now I want you to put a star by this one because this is one that we miss a lot. And if you try to take any shortcuts, this is going to be a problem. Last time I went to Kirby Lane, the bill including the 30% tip was $106.60. What was the cost of the food including tax? Okay. All right. I'm going to go back to my percent equation. So I have some percent of a reference value is equal to a compared value. Well, what is the compared value here? The 30% and the percent and the compared value are the same. So my compared value is 106.60. Which is the total bill, which means this must be the food, which is what I don't know. So I'll call that X. But here's where I have to really think about the percent. This is the bill as a number, but the percent represents the food, our reference value of the food, plus the tip. So I'm going to have the food plus 30% more, which is 130%. So this is 130%. So my equation becomes 1.30 times x is equal to 106.60. Divide both sides by 1.30, and I get that x is $82. That is the cost of the food. Okay. Okay. The cost of a Tesla is $90,000 and the cost of a Honda Fit is 70% less than the cost of a Tesla. I actually think it's a little bit less than that. Okay, so what is the cost of the Honda? Okay, well this is going to be, since this is less than, I'm going to take the reference value with the Tesla, and then I have to subtract 70%. So 100% minus 70% is 30%. So this is telling me that the Honda is 30% of the Tesla. Oh. Okay. So to find the cost of that, 0.30 times the Tesla is the Honda. So now I'm going to do 0.3. So that's 27,000. Okay. All right. The Honda is 30% of the Tesla, which means it is 0.3. Remember, times is the percent of as a decimal. Okay, I'm going to switch videos.